Hello everyone, myself Subrata Shah, faculty of Dr. Sudhir Chandrashur, Institute of Technology and Sports Complex, and today I am going to discussing about the two main components of the power drive or the drive lines of a vehicle. So that is propeller shaft and universal joint. Okay, propeller shaft, it is also known as a cardan shaft also. So propeller shaft, these are the propeller shaft drawing diagram, and this shaft transmit the power from left side, that portion is in gearbox, and in right side that is differential. So it transmit the power from gearbox to the differential or the rear axles. So normally this propeller shaft is a tubular section and is made one or two pieces of construction also. So the two pieces propeller shaft arrangement is supported at the midpoint by the rubber mounted bearing, and the short drive shafts are incorporated for transmitting the power from final drive assembly to the road wheels in both front and rear wheel drive vehicles. And this propeller shaft basically transmit the power or torque at an angle. Okay, so it transmit the power not in a straight line but also in an angle. In that is the main difference in between normal shaft to a propeller shaft by here. And this propeller shaft must have to strong to resist the twisting action of the driving torque, and it should be absorb the torsional shocks also, and it must resist the natural tendency to sag under its own weight, because the vibration occurs when the center of gravity does not coincide with the axis of the shaft. A tubular section propeller shaft is normally used because it has low weight. If we are using the solid shaft, that will increase the weight of the shaft as well as the weight of the unsprung weight of the vehicles. And second one, maybe it provides a large resistance to misalignment, especially in case of sagging due to the huge vibration, because huge vibration is available in the propeller shaft area, and it has obviously torsional good torsional strength, and it provides low resistance to change its angular speed, and which arise when a hook type coupling is used to drive the shaft. Since a propeller shaft often rotates at high speed, especially during the use of the overdrive gear, and it must be manufactured and repaired, and also maintain a good design specification and good designing limits also. So these properties should have in propeller shaft, because propeller shaft uh, is transferring the power from the production unit or the multiplication unit to the rear wheel drive. The critical speed of the propeller shaft varies directly as the diameter of the tube and inversely as the square of the length of this shaft, of this propeller shaft. And therefore the diameter is selected as large as possible and length as short as possible to keep the critical speed frequency of the shaft above the driving speed range. And propeller shaft over 1.5 meter length between universal joint can cause the unbalanced problems. And so shaft lengths are minimized by using long transmission extension housing and center universal joint with two pieces propeller shaft. The, the universal joint is supported by a center supported bearing and which is installed in the vehicle chassis frames. The propeller shaft tubing is usually rolled from sorry. The propeller shafts are usually rolled from propeller shaft tubes is generally rolled from the flat sheet and straightened within point near about 0.2 to 0.3 millimeter and run out and balance within near about point 0.0002 kg meters, and this keeps the center mass very nearly on the longitudinal axis center to minimize wheeling speed of the propeller shaft. So the critical speed is, if I denoted the critical speed NC, that is equals to 60 pi square by 2 pi L square into root over EI by rho A RPM. That will be the critical speed, where I is the moment of inertia of the shaft sections, that is pi by 64 into outer dia to the power 4 minus inner dia to the power 4, that is the I, and A is the cross sectional area, that is equals to pi by 4 the outer square minus inner square, and L DO is the outer diameter. If DO is the outer diameter and DI is the inner side diameter, and length is the L of the shaft, and G is the acceleration gravity, is the modular elasticity, and rho is density of steel, that is mentioned here. And so in if we minimize this reaction is equations, that NC is equals to 1.8 million and 90,000 into root over outer square diameter square plus inner diameter square by length shaft length square. Now once again, so a critical speed of the shaft so is to be designed that is about 60% higher than the engine speed at the maximum power. So it is our designing criteria. It is in our designing criteria. And propeller shaft can also be designed for a given torque rating which is in the torque required to stretch them to the elastic limit also. And if TE, if we denoted this TE is the engine torque, then G is the overall gear ratio, T small t is the torque transmitted by the propeller shaft, and TD is the design torque for the shaft, that is means theoretical, and T is the actual, and Fs is the safety of factor. The safety of factor is near about recommended 3, I think. IP, the polar moment of inertia of the shaft, that is pi by 32 d outer to the power 4 minus inner to the power 4, and y is the distance from the neutral axis of the outermost fiber of the shaft, d outer diameter by 2 means outer radius, you can say. Then TT is equals to the TE, means transmitted torque is equals to the engine torque, the torque provided by the engine, and TD by IP, that is the design torque by polar moment of inertia, is always equals to safety of factor by the safety of factor of the safe shear stress by the neutral axis distance, and TD is equals to Fs into IP by Y, that is also equals to pi by 16 outer diameter to the power 4 minus inner diameter to the power 4 by d into Fs Newton meter. That is the formula, and TD equals to TT into factor of safety. So the design torque of a shaft is near about the 3 times of theoretical torque of the propeller shaft. Okay, because we consider the factor of safety is near about the 3. Yeah, one more thing, nowadays we are using the uh, composite shaft. So there are some advantages of the composite shaft over the conventional two pieces shaft. There are mainly the weight reduction near about 40 to 50% weight reductions, and high internal shock absorbing property also, and less noisy and less vibration performance, and one is and another is the less corrosion, means the corrosion resistance power is high for new kind of composite shaft, propeller shaft. Now universal joint. So there are so many types of universal joints. These are the most popular type of universal joint used in these two type of these two pictures shown. These are the most popular type of universal joints used in nowadays. And these universal joints are capable of transmitting the torque and rotational motion from one shaft to another shaft when their axes are inclined to each other by some angle. So the speciality of the propeller shaft is basically it contains the universal joint. That's why that propeller shaft are or can transmit the power at an angle. So universal joints are incorporate of the vehicle's transmission system to perform uh, a better way or better conditions, like propeller shaft end joints between longitudinally front mounted gearbox and rear final drive axles, and rear axle drive shaft end joints between the sprung final drive and the unsprung rear wheel stub axles. And the universal joints have movement only in the vertical plane when they are used for the longitudinally mounted propeller shaft and transverse rear mounted drive shaft. Okay, so that is also one kind of advantages of using universal joints. And these joints have been designed to absorb the torque and speed fluctuations and to operate reliable with very little noise and uh, having also good life. Okay, so these are the criteria of the universal joint. Now how many types of universal joints? There are so many types of universal joints, like hook joints, uh, cross type joints, cross type with rubber bush joint, laid up joint, and donut rubber coupling. So these are the types of the universal joint. In first one, that is the cross type joint. In this type of joint is also called the hook coupling, in the name of Robert Hooke, who invented this kind of uh, driving mechanism. And these cross type joints are the uses two yokes that is set in 90 degree to each other, and a cross shaped block joints blocks the uh, joints of yokes. A special kind of viscous oil or lubricating oil is used in final drive for bearing lubrication, that is also very important to lubricate the bearing. So in the D type picture, that is the layer up type of joint. Then this type of joint is made by the uh, Laylaw, first introduced in by the company Laylaw company, and it uses the constructed with series of rubber bushing, and it uses a number of molded rubber blocks also, which is specially shaped cavities at the end side, and these blocks are sandwiched between the two steel pressing to the each other, and each shaft is connected by the means of the fork to alternate for transmission through a small angle, and also the block accommodate a small axial and angular movement for the shaft length alteration and torsional damping also, and this coupling is relatively large in diameter, and this layer type of joints offer the several advantages over the cross type cross type universal joint, that it doesn't require any lubrication. In case of cross type, we have to use the lubrication oil, and in this layer up joint, uh, it, it's capable of driving through the bump angles up to near about 15 degree, and it allows for the axial movement required to the splining of the shaft. So these are the advantages, and this is the donut type, and the size of this universal joint is quite large, and the great flexibility of this joint provides the soft cushioning effect on the driveline, and this absorbs the majority of torsional shocks which generated by the action of other joints or by the vibration from either the engine or road wheels. The synthetic rubber coupling shows uh, that it shows like the circular in shape, and yeah, and it's surrounded with the cylindrical steel plates, uh, the cylindrical steel plates which are bolted alternatively to the C-arm fork which is fixed on the shaft, and the advantage of this donut type of universal joint is almost similar to the layer type of universal joint. Okay. Okay, now my today's topic is over. Thank you.